Hello, this is homework number 5 for EGR 480, and this is a incrementer decrementer using buttons, which have to be detected on the clock. So, the first thing we have to do is import our buttons, which are standard logic ins. Then we use our 7-segment displays, just like we did with the last homework. Now we have to declare signals for the up, down, and clear edges, and a vector to represent, a number in the range of 0 to 9, because that's all we're going to be working with on our 7-segment display. So once we turn on our anode, we can start our first edge detect, which is to detect the rising edge of the up the increment. Then we start our second worker edge detect, where we check for the rising edge of the decrement. And then the same thing for our clear button. Now we have our actual logic that handles whether or not we can increment and decrement. So if we do detect a clear edge, it just sets the number equal to 0. If it's the up edge, then first we check if it's equal to 9, and if so, then we don't do anything. But if it's less than 9, then we increment it. And then the opposite for decrementing. So it's very simple. The last thing we have is a switch case to drive our 7-segment display. So the only thing that we have that's not the top file is the edge detect. This is a submodule for detecting the edge of anything on the clock. Essentially what it does is it checks the state to see if the previous state is not high and the current state is high, then that is an edge. That's essentially all this module does. Now the last thing we need to show is the test bench. And our test bench is very simple. We pulse specific button inputs and then check the outputs to make sure they're correct. And we can loop through these button inputs as well. It's hard to tell because, again, this is a 7-segment display as our output, but it is incrementing and decrementing correctly, and I can show it on the FPGA itself. So the up button, you have to be careful. If you hold it down, it'll keep, or I think it's called debounce. So if the contacts of the button make more than one connection, then it will increment or decrement more times than it's supposed to. And the only way to solve this would be to write a somewhat convoluted debounce algorithm. So if I'm just very careful, which it's really hard to do, I can cycle one button at a time, but it will seemingly at random do more. And then at any point, the center button clears back to 0.